Week 9, EDM 60204, and we are looking into point, line, line segment, and also ray. Let's look at the lesson objectives. At the end of this lesson, you should be able to identify what is a point, identify lines. Okay, so when we identify lines, we are looking at three types of lines. So we have lines, we have line segment, and we have ray. And then you should be able to explain what are lines, what are line segment, and what are rays. The next thing is to identify surfaces and curved surface. Explain surfaces and curved surface. And then draw a relationship between surfaces, lines, and curved surfaces. So, what are points and what are lines? So, the origin of lines is from a single point. Right, let's have a look at this. What is a point? Point is the fundamental element of geometry. Everything starts with a point. So if we put the tip of a pencil on a piece of paper, as you can see here, and press it lightly, we see a very small mark on the paper. So this mark is known as a point. The smallest mark denotes the existence of a point. So we can say that a point, it does not have any length, it does not have any breadth or width or thickness, but it has a definite position. So if I put a point here, the position is on the right. If I put a point here, the position is on the left. So it can be named by a capital letter of the English alphabet, like A or B or C, etc., etc., etc. So this point here, we call it point A. So it says, I am the honorable point. Now let's look at lines. So to draw lines, we need to start with a point. So here, a line is when two points are made at a distance on a surface and are joined by a pencil, and then part of a line is formed. So the part of the line will be straight if the surface is plane and curved if the surface is curved. So it really depends. So the first one here is the part of a line. So this is a straight line and this is a curved line. Okay, so it's a curved surface and it's a straight surface. Alright, so a line is indicated by drawing arrowheads on both sides of the part of a line. As you can see here, this is one arrowhead, this is another arrowhead, so it's a double arrowhead. So a line actually does not have an end, no end, and it has not a definite length. So that's a line. So this is a line. Now we have double arrowheads at the end. This is to show that it goes for infinity. Okay, so the name of a line is indicated by two capital letters of the English alphabet. Now this symbol is placed over the letters as A, B or C, D. For example, this line, this is A, this is B. So this line is called the AB line. Now let's take a look at the different types of lines. Okay, so people or students may be asking how many types of lines are there in geometry. Okay, let's look at the different types of lines. So we have straight line, right? So the first one is a horizontal line, and the second one here is oblique or slanting or diagonal. And the third one is vertical. Okay, so vertical is a straight line like this one. And that's oblique or slanting or diagonal. Next, we have curved line. So curved lines are lines shown below. So they are all curved lines. So this is the first one. This is the second one. This looks like an S. And this one looks like a U. Okay. Now, types of straight lines. We're going into straight lines. We're not going into curved lines yet. So how many types of straight lines are there? Let's have a look. So for straight lines, we have the horizontal line, which is actually drawn like this. Okay, so straight lines may be drawn in different directions. So when we are talking about different directions, it's either horizontal or vertical. So this is the horizontal lines. And we have 2 points there. One is A and one is B. Now when you put the points, that means the horizontal line will start from A and then ends at B, even though we still have this on both sides. So that means, let's say, that is a person who walks from point A to point B and then stops. Okay, so this is the AB line. Let's go to another one. Vertical lines. Okay, vertical lines are like this. Okay, and again, you have the 2 points here to show you that we start from C, and then we end at a D. So then you can actually calculate or measure, okay, the length. Okay, the next one is the oblique or diagonal or slanting lines, which are drawn at a certain angle. Okay, so explanation on different types of lines that we have done just now will help the students to understand the difference between straight line and curved line and how the lines are drawn in different directions in geometry. Remember spatial sense. Okay, so when we talk about spatial sense, you must know what spatial sense is all about. There are 3 components there. Okay, so you have to know what are the 3 components. But the most important thing will be the mental rotation. So for the slanting lines, we have 2 points as well. One is E. We start from E and we end at F. G and H, we start at G and we end at H. But you can still draw the line, the oblique or the slanting line with these arrowheads. Okay, that is to show that the line is actually ongoing. It doesn't stop. So if you have any questions regarding lines and types of lines, please do drop your questions in the comment box for this week. So let's continue. Line segment, ray, and line geometry. Cool shades. Okay, so now we are looking at more than just lines. We are looking at line segment, we are looking at ray, and we are looking at line geometry. Okay, so the first one is a line. When it is called a line segment, it is shown as below. So when you put 2 points at on top of the line, then this will become line segment. Like for example, A and B. Remember, we start at A, okay, and then we end at B. So this is line segment AB. Now for this one here, the oblique or the slanting or the diagonal, we start at C, we end at D, and these are points showing the start and the end, or the start and the end on the other side, okay, on a line. Now, okay, so only one line can be drawn passing through any 2 points, but a number of lines can be drawn passing through a point. Okay, so on a line, on a single line like this one, you can place 2 points. Okay, so you can place 2 points. That means this line can go through 2 points, right? But if you start with a point like this one at 0 or O, then you can draw a lot of lines like this one. 1, 2, 3, 4. 4 lines. Okay, and you can add some more if you want to. Like, let's add, okay, like this one. Sorry, it's not straight, but it should be. Okay, and then this one, and then this one, and then this one. So there will be more lines going through a single point as compared to when you place points on a single line. So this is another line segment, CD. Okay. Now rays. When we talk about rays, let's imagine that there is a sunlight. Okay, when we see sunlight early morning, the sunlight or the sun ray actually comes from the sun. That is a starting point. Okay, that is a starting point. So when there is a starting point, so we call it a ray, like this. So we can use a torchlight to teach our students what rays are. That means this is our starting point, and then the ray coming from this torchlight will go on and on and on and on and on and on. Okay, so that's why we have the arrow showing that it travels in a straight line. So as we were saying, sun ray starts from the sun and it goes on a direction up to endless space. Okay, so when we talk about geometrical ray, we consider a special kind of line which starts from a fixed point and goes into any distance or any direction, but it's a straight line, in a straight line. So like for example, this one is a straight line. This one is also a ray. It's a straight line as well. So the name ray is given with 2 capital letters like this, 2. So one letter is written at the starting point of the ray, and the other letter is written near the arrow at the end as AB or LM. So a line segment, and ray are called one-dimensional figures. Okay, one-dimensional figures as they only have length. Remember that. They only have length. So they are one-dimensional figures. Okay, so let's compare. Okay, so let's compare these three. So we have line segment, we have ray, and we have line. So let's begin with line first, because that is the beginning of line. So as we can see, there are no endpoints in a line. Okay, there are no endpoints in a line. So you have double arrow. Okay, but in a line segment, it has two endpoints. So the two endpoints here, it could be A and B. It could be A and B. And then for a ray, it has one starting point, like the torchlight, okay, or the sun. Now the second one is that for lines, there are no endpoints. So the line goes on and 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 on. Okay? So a line cannot be measured. A line cannot be measured. Now for line segment, it can be measured because you can see that there will be 2 points. So when it's 2 points, that means, for example, like this, we have point A and then point B. Then you can actually measure the length from point A to point B. And then for rays, it has a starting point, but no other end point. So length cannot be measured. So that means for line as well as for ray cannot be measured, but for line segment it could be measured. The third one is this is the symbol for a line, okay, with 2 arrowheads. And then for a line segment, it's like this, plus it has 2 points. And this is the symbol for a ray. So by being able to explain, compare and contrast these 3 types of lines, it will help the children or the students you are teaching to understand the different fundamental elements of geometry and their distinction. So if you have any questions regarding the 3 types of lines, please do drop them in the comment box in the Google Classroom. So let's look at perpendicular line, parallel line, and intersecting line. So we have 3. We have number 1, perpendicular line. We have number 2, parallel line. And we have number 3, intersecting lines. Okay, lesson objectives. At the end of this lesson, you should be able to describe perpendicular and parallel lines. And if we have the time, we'll go to the intersecting line. So the first one is parallel lines. Just like what you see here in the short movie, in the short video, these lines are all parallel lines. They will never intersect with each other. They will go side by side forever and ever and ever. Okay, so what are parallel lines? Parallel lines can be defined as the same distance apart. So lines that are parallel means that they will always be same distance apart, which is also called as equidistant, and never meet. Okay, they will never meet. So they also they also point in the same directions. Okay, so just remember these words, always the same distance apart and never touching. Okay, so you can see red line and blue line here in this example. They are parallel and they are of the same distance here and here, here and here. They will never touch each other. So they will go on and on and on and on and on, the same direction, but they will keep their distance away from each other. Okay, so this is parallel line. Okay, when parallel lines get crossed by another line, this line is called transversal line. You can see that many angles, so we're looking at angles now, are the same as in this example. You can see the example here. These angles can be made into pairs of angles which have special names. Okay, so now you need to remember the names of the special angles. Okay, so you can click on this link to go and see what are the angles that are the special angles. Okay, so we have the first one. Now these two, this line and this line, they are parallel. They are parallel. Now this line here is the transversal line. Okay, so it cuts across. And then we have angles like A, B, C, D, E, F, G, H. This is taken from Maths is Fun 2018. Okay, so parallel line are the ones that's highlighted as yellow. Okay, so the transversal line is highlighted by yellow highlight. So you can see that that's the transversal line. Now these are parallel lines. So you can see that these are the parallel lines highlighted by yellow highlight. And then we have vertical angles. Okay, so vertical angles are opposite of each other. So you can see that A equals to D. That means the angle for A is the same as the angle for D. Okay, so this is vertical angles. Next, we have another vertical angle, which is C and B. Okay, so these are other vertical angles that you can look at. We have E and also H, and then another one will be F and G. Next, we look at corresponding angles. Okay, so corresponding angles will be on different sides, like A and E. A and E. So these two are corresponding angles. Other corresponding angles will be B and F. This is B, this is F here. Are there any more? Yes, there are. C and G. So this is C, this is G. These are corresponding angles. Next, we have D and H. So the D is here, the H is here. So you see that the corresponding angles are angles that are on the same sides but on different lines. Okay, alternate interior angle. So interior, because this is one line, this is a second line, so the interior will be here. Okay, so this is the interior. So alternate, that means they are on different sides. So C and F, they are on different sides. So let's find another one. The D and E. So this is another alternate interior angles. Now, if we have interior, we will have exterior. So here, this part is exterior. And this part here is also exterior. Okay, remember the interior is here. So for exterior, alternate exterior angles, they have to be alternate on different sides. So it's A over here and H over here. Another one will be B and also G. Consecutive interior angles. So we look at the interior, this part. So they are not saying that it's corresponding or alternate. That means they will have to be side by side, here and here. Okay, that means C plus E will give you 180 degrees. And then there will be D plus F will give you 180 degrees as well. Okay, now we're not going to do this, but if you have the time, you can just go here to have a look at what exercises that they have. Okay, but I'm not asking you to do this. You have to do it on your own during your free time, yeah? Okay, testing for parallel lines. Let's see, how do we test for parallel lines? Okay, some of those special pairs of angles can be used to test if lines really are parallel. So we want to know if the lines are really parallel. Okay, if any pair of corresponding angles are equal, okay, or alternate interior angles are equal, or alternate exterior angles are equal, or consecutive interior angles add up to 180 degrees, then all the lines are parallel. Okay, so all the lines are parallel. So at this point, you do need to know what are corresponding angles, what are alternate interior angles, what are alternate exterior angles, and consecutive interior angles. So then you can determine whether those two lines are parallel or they are not parallel. Okay, so this is testing for parallel lines again. All right. Okay, so I have to make it a bit brighter because I can't see really well. Okay. This is the same actually this is the same with the previous slide that we went through just now. Okay. So this part is where we want to determine whether the lines are parallel. So corresponding angles are equal, and you have to know corresponding angles will be, these are the two parallel lines. Okay, parallel lines, and this is the transversal line. So one is interior, one is exterior, and they have the same angle. So these are corresponding. So they should not be in the same interior. One is exterior and one is interior. Okay. And then consecutive interior angles. will add up to 180. This is the second one here. Okay, so when you look at interior angles, it will add up to 180. So this is the interior. So these two will give you 180 degrees. So if they don't add up to 180 degrees, that means the lines are not parallel. Okay, so because if it is, then it will add up to 180. If right now it adds up to 182, that means these two lines are not parallel. Now this line here, these are what we call as alternate interior angles, and they have to be equal. That means it shows that the two lines, this line and this line, they are parallel. So this is how you actually use the different types of angles to determine whether the lines are parallel or they're not parallel. Okay, so we have looked at straight parallel lines. So now we are looking at parallel curves. So curves can also be parallel when they always have the same distance apart, which is called equidistance once again, and they never meet. For example, railroad tracks. Okay, so just like this one here. So we just put this. So these are railroad tracks, for example. They will never meet. This line will never meet with this line. So we have the red line and the blue line. And this circle is also parallel curve because they will never meet. The blue and the red lines will never meet. We also have parallel surfaces, and two surfaces can be parallel. They are always the same distance apart and never touching. In our class, in the X space, okay, let's say this is a building. So this and this and this, they are all parallel. Okay, so this is floor number 1, floor number 2, and floor number 3. So floor number 1 and floor number 2, they are parallel. So they are called parallel surfaces. Now, in other examples, they might have surfaces that looks like this. So as long as the length from one space, from one surface to the other is the same throughout, this is what we call as parallel surface. Okay, so we're done with parallel lines. Let's look at perpendicular lines. So as you can see from the animation here, perpendicular lines is where you can see 90 degrees, 90 degrees over here, 90 degrees over here, 90 degrees over here, and 90 degrees over here as well. Okay. Right, so these are some examples of perpendicular lines. Perpendicular, it just means at right angles. Okay, so when you place two lines, it must give you 90 degrees. So the red line is perpendicular to the blue line. Let us see here in this example, the red line is perpendicular to the blue line. Okay, when you see that the angle is 90 degrees. The second one here is the same as well, where you see 90 degrees. Okay, so perpendicular, when the angle is actually 90 degrees. So we don't really need to also know that there was 90 degrees, but we always need to determine by looking at 90 degrees. For example, in this drawing here. Okay, so you will need to use your protractor, okay, where there are angles there, right, to determine that this is 90 degrees. So if you have any questions regarding perpendicular lines, please do drop them in the comment box. Okay, let's look at surfaces. Is it faces or surface? Okay, so what's the difference? Okay, definition. Let's look at definition of surfaces of the solids or 3D figures. When we look at 3D figures or 3D shapes, we can find that some are flat, some surfaces are flat, and some are curved. So like cylinder, this is curved, this is flat. Okay, these faces are not only seen but can also be touched, like cylinder. When you buy Coca-Cola canned drinks, then you can actually feel the curved cylinder. Now these are called the surfaces of the solids or 3D figures. Okay, so remember, faces are flat surfaces. Okay, this is found only in geometry, where we define faces which are flat like this. Okay, they are from flat surfaces, so they must be flat surfaces. Only then you can call them a face. If it is something like this, which are curved surface, you just need to call them as curved surface. You don't call them as face. Okay, so curved surface, face, and face. Okay, there you go. Alright, so we have many faces for cube and also triangular prism. But for a cylinder, we have curved surface. Alright, there are two types of surfaces. We have the plane surface, and then we have the curved surface. Okay, so plane surfaces are called flat surfaces. Okay, so the geometrical term will be plane surfaces. So plane means flat. So objects having plane surfaces are called plane objects. Right? So surfaces like the book, the matchbox. Almirah is actually a wardrobe such as this, okay, or a cupboard. It's either from Portuguese or Latin. And then we have tables like this one here. Okay, so these are plane surfaces. These are plane surfaces. So these are plane surfaces. Here we can see the plane surfaces on top, the plane surfaces here, and the plane surfaces over here. So anything that is flat surface, or they are called plane surface, we have another name, which is a face. Okay, now by introducing this term, you might get a misconception from your students, because they might think that a face must look like their face, where you have eyes and nose and cheeks, and mouth and teeth, eyelashes, and so on. Okay, but in geometry, we call flat surfaces or plane surfaces as a face, with no eyes, with no nose, with no ears, with no mouth, with no cheeks. Now the other one is curved surface. Curved surfaces that are not flat, they are called curved surface. So for example, a ball here, you can see it three-dimensionally, front and also the other side. And then we have an apple, yummy. And then we have an orange. Okay, so these are all curved surface. Or we can call them spherical surface. It's because there's only one surface, which is the curved surface here. So some objects which have both plane and curved faces of curved types of surfaces, like a drum and a clock. So these are objects with both types of surfaces. So a drum such as this, for example. Okay, so you have the flat surface, and then you have the curved surface. So if you have any questions regarding the surfaces, please do post them in the comment box. So we have come to the end of week 7 lecture. So what you need to do is, after you have watched the videos and you understood about lines, line segment, and also ray, and then we have parallel lines and perpendicular lines. So in your notes, you can draw a mind map. Okay, you can draw a mind map. And add that into your lecture note for week 9 lecture. Okay, so yeah, this one is the old one for my other students. So this is just for you to show that you have done the mind map, that you have already watched this video. And that's it for now. Bye.